All right, let's do 2.3. We're answering these questions using the given compounds. Right, 231. Write down the structural formula of compound B. Right, compound B. What is the structural formula? The structural formula is showing us which atom is attached to which, right? And then the atoms are represented by their chemical symbols, and the bonds are represented by the lines or the straight lines that we're going to use. So we have CH3 and then CH2. So we have this C. It is attached to what? To three hydrogens. So they'll be like, this is the hydrogen, another hydrogen, another hydrogen. There must be 4 bonds around carbon. Then it means this carbon also be joined or bonded to another carbon. And then if you check here, there are how many CH2s? There are 3 of them. So we have 1, 2, 3. And then each carbon here is bonded to 2 hydrogens. So there's a hydrogen there, there's hydrogen there, hydrogen there, hydrogen there, right? And then also, this is the third one, still hydrogen, and then hydrogen. Now we have 1, 2, 3. The fifth one is going to be this one, bonded to oxygens, 2 of them. So this should be this bonded to an oxygen and then another oxygen there. Okay, right. And then oxygen, around oxygen there must be 2 bonds. And then there's another one bonded to a carbon, and then with 3 hydrogens. Just that. Just know that the structural formula, you're using the chemical symbols, showing you which atom is attached to which. And then your bonds, you use what? The lines, like that. What type of a compound is this? This should be an ester from the reaction between a carboxylic acid and an alcohol. Then 232, structural formula of compound C. This is 4-ethyl, so it means we have an ethyl group bonded to the main branch. Then 3,3 difluoro, it means we have 2 fluorides and they are both attached to carbon 3. And then hexane, this is giving us what? The main branch, right? Hexane means how many carbons? 6 of them. So you can start with those carbons. 1, 2, 3, 4, 5, 6. So we have those carbons, 6 of them. And then at 4, this number is 1, 2, 3, 4, 5, 6. Right, at 4, we have an ethyl group. So we can have an ethyl group here. So we have CH2 here, and then bonded to another carbon, and then CH3. That is the ethyl group. This whole thing here is the ethyl group attached to carbon 4. Difluoro, carbon 3. So we have fluoride there and fluoride there. Fluoride, fluoride. Done. And then the rest, we just put the hydrogens. So it's going to be like this. Make sure there are 4 bonds around the carbon. It's going to be like that. In 2, 3, 3. Right, the general formula of the homologous series to which compound E belongs. Compound E, we say that is an alkene. So alkenes, what is the general formula of the alkenes? It will be Cn and then H2n. Just remember this. You have to remember this. From alkanes to alkenes. Alkanes will be CnH2n plus 2. Then for the alkenes, remove these 2. You remain with CnH2n. Then for the alkynes, further remove the 2, but you no longer have a 2 to remove. So we're going to say minus 2. So it's CnH2n minus 2, like that. So you have to remember. Okay. For the alkanes, alkenes, alkynes, like that. All right. And then 2, 3, 4. What is the structural formula of the functional group of compound F? Functional group of compound F. So what do we have here? We have this. So what is that? That's a ketone. That's a ketone. We can write that as the functional group. And then that is the ketone there. Then you can put R there. and then another R there. Or even if you write it like this, then we have like this is still okay. Right. That is the functional group of compound F. Right. The IUPAC name of the alcohol needed to produce compound B. Like I said, we said that compound B is what? This is compound B. We talked about it. Okay, this is an ester which comes from the reaction of carboxylic acid and an alcohol. So you can divide actually, you can actually divide this molecule into two parts, right? So what you do, you cut here where there's the single bond. The carbon is bonded to two oxygens here. It's bonded to an oxygen with a double bond and also an oxygen with a single bond. So you divide where there's a single bond like this. The one with the double bond is coming from the carboxylic acid. The one with the single bond is coming from the alcohol. And then this is the O coming from the OH. So meaning that the alcohol here will be CH3 and then OH. Okay, this O is the O from the OH. And then what is the name of this alcohol? This is methanol.